In this lecture, we will explore the next components of the chemistry of life. And so in this is lecture part 2, Chemistry of Life, part 2. Okay, Chemistry of Life, part 2, let us begin. Okay, what we're going to do here, we're going to draw two atoms. Well, one atom to start out. Okay, let's put the center of the atom here. And the atom is going to have its protons, 11 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. With 11 protons, that makes this atom automatically the sodium atom. It's a sodium atom. Okay, and let us give it, or the sodium element, and let's give it 12 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And so with 12 neutrons and 11 protons, that makes this the sodium 23 isotope. Okay. Now let's give some energy levels. Let's give it 3 energy levels. 1, 2, and 3. Okay. Now on each of these energy levels we will have electrons. Okay. The first energy level is full when it has 2 electrons. So 2 electrons go in the first energy level. The second energy level is full when it has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And so now that gives us a total of 10 electrons. And the last energy level is full when it has only 1 electron. And there we are. Now this is the sodium atom. Okay. And we'll label that. Well, we can go ahead and label it now. Let's label this the sodium atom. Give me a good pen here to write this. I'm just going to put the symbol sodium Na atom. Okay, now there's our sodium atom. Now what we want to do here, we want to make a kind of make a copy of this. Okay, because I want to use this somewhere else, but we want to keep this copy. So we're going to put the copy of this over here, and we'll change the copy. So here's the sodium atom here. And what we'll do here, we'll move this one over here, kind of out of the way. And so currently this one, let's just look at the second one here. This is the sodium atom. It has the same number of protons as it has electrons. I'm going to get rid of this word here, sodium. I'm going to get rid of the word atom for now because it's, make sure I have the right one. Okay, I do. Because although it's the atom now, we're going to make it not be the atom. Now all atoms are all atoms all atoms basically want to have either a complete number. They want their energy levels, the electron energy levels, to be either completely full or completely empty. Now if we look at this first energy level, it has 2 electrons and that's full, it's happy. The second energy level has 8 electrons, it's full and it's happy. The third energy level has 1 electron, so completely full would be 8, and that would look like this. So add 7 more. 1, 2, 3, 4, 5, 6, 7. Now the third energy level is happy. However, this is not what happens. It's harder to become, because it only has 1 electron, it's harder to become completely full. So sodium elects to become completely empty. And that's what happens here. And I'm going to actually get rid of this here because we don't need this. And so what happens, this electron, it just doesn't disappear, it just goes away. This electron goes away. Now the remaining particle here, the remaining structure, has 10 electrons and 11 protons. So it has 11 positive charges and 10 negative charges. And so what happens here is that energy level is kind of empty now. So it doesn't completely go away, but it served its usefulness. And so here we have the sodium atom that has 1 more positive charge than negative charge. And so we call such an atom, we call such a structure an ion. We call such a structure, I don't want to put it there actually. Actually I want to put it on its own energy level. I mean its own layer. And so we call this an ion, or the sodium ion. And the sodium ion can be written as Na plus, sodium with a positive charge. Okay, let's just review this. Here we have the sodium atom. It has 11 protons in the nucleus and 11 electrons orbiting the nucleus. The sodium ion, however, has lost 1 electron. Now it has 10 negative charges and 11 positive charges. This is the sodium ion. Okay, let us continue with another atom. This atom is going to be the chlorine atom. Okay, let's put the region for our nucleus. Okay, we're going to put the nucleus in this region here. That's going to be our nucleus. And now let's put our electron orbitals. I'm going to zoom into this area here. Okay, let's put our electron orbitals here. Okay, again, just like sodium, chlorine, it has three orbitals for the electrons. 1, 2, and 3. Okay, and we're going to get rid of sodium for now so that it won't be in the way. We're going to get rid of the sodium atom and the sodium ion. Okay, now in the nucleus of this atom, we're going to have 17 protons, so a lot of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There are going to be 17 protons, and there are going to be 18 neutrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. And so, because this has 17 protons, this structure is, or this atom is the chlorine atom. And because it has 18 neutrons, it becomes the chlorine 35 isotope. So this is the chlorine atom. So we can go ahead and put that here now. So we'll know this has to be the chlorine atom. We aren't going to be as specific right now. We are going to be very specific. Isotopes are more specific than atoms. And so we just need to know, we just want to know what atom we have now. We are concerned with the isotope. Only when you're dealing with nuclear chemistry are you really involved with the isotope. So we don't really care what isotope we have here. Now let's identify the electrons. Okay, and so because it has 17 protons, it's going to also have 17 electrons. So here we go. 1, 2. The first energy level is happy with 2. 3, 4, 5, 6, 7, 8, 9, 10. The second energy level is happy with 8, so that gives us 10. 11, 12, 13, 14, 15, 16, and 17. Okay, and this is the chlorine atom. Okay, let's zoom out here. Okay, now the chlorine atom, notice it has only 17 electrons. The first energy level is happy, it's full. The second energy level is happy, it's full with 8. The third one is unhappy because it only has 7 electrons. And so it's going to do something to fix this. Okay, so let's make a copy of this. And now let's move this entire chlorine atom over here so that we can fix it, so that we can fill that outer energy level. Okay. Now what's going to happen here? It could either do two things. Okay. This chlorine could do one of two things. It could either lose the 7 electrons, and then its outer energy level would be filled, or it could simply gain 1, and it's simpler to gain 1. So this is what it does. And so here the chlorine atom simply gains an additional electron. Now it's happy. However, it has one more negative charge than positive charge. And so this chlorine atom is now no longer an atom because it has another electron, because it has a charge now. And so for that reason we call it the chlorine ion. It is now a chlorine ion. Okay, so let's zoom out here, and now let's look at everything we've talked about so far. Let's see here, make sure I have space for everyone. I think I need to move my chlorine atom down a little. If I can, move that down, and if I could, move my chlorine ion down a little. Okay, here we are. And so now we have the sodium atom here, the chlorine atom here. Over here we have the sodium ion, which is Na+. Down here we have the chlorine ion. Oh, I'm going to put the charge on this one. The chlorine ion is going to be Cl-. Now, if an ion has a negative charge, we called it an anion. A-N-I-O-N. And you can use N to remember negative. An anion has a negative charge. And if an ion, like sodium up here, has a positive charge, okay, let me zoom in here. If it has a positive charge, we call it a cation. A cation. And so that's C-A-T-I-O-N. And you can remember the word, or remember it has a positive charge in it. The T looks like a plus sign. So cations are ions that have positive charges. Anions are ions that have negative charges. And these are ions. Okay, on this slide we're going to discuss some of the important ions in the body. And there are quite a few of these ions that are important for us. We've seen two of them already, and let's identify them this way. Let's identify the cation, which is the positively charged one. Okay, we'll put the cation here. That's the positively charged ion, and the anion here. That's the negatively charged ion. So let's put a plus under this one and a minus under this one. And let's identify some of these important ions in the body. One cation that we've already seen is sodium. Sodium is an important anion, sodium is an important cation. An important anion is chloride, the chlorine anion. Another important anion in the body is, well, let's do a cation first. Another important cation is calcium. It has two positive charges. Another important cation, I guess we could have magnesium. Magnesium is an important cation, and it has two positive charges. Now, how do cations and these anions get into the body? They get in the body when we intake salts. Okay? And there are a variety of salts that we can take into our body. Okay. If you have the sodium cation and the chloride anion, we call the salt sodium chloride, which makes sense. So the salt in this case would be sodium chloride. Okay. If you have the calcium cation and the chloride again anion, we call the salt calcium chloride. which makes sense, calcium, and chloride. If you have the magnesium, cation, and again the chloride anion, we call the salt magnesium chloride. Let's do one more here. There's one more anion that we can identify, and this anion is bicarbonate. It's a polyatomic one, which means it's made of more than one atom. HCO3, and it has a negative charge, and it most oftentimes joins with sodium. And so here we have sodium is the cation, and the anion is bicarbonate. And so this salt is going to be called sodium bicarbonate. Sodium bicarbonate is the salt. Okay, and so these are some important salts that are in the body. Sodium chloride, which is made of sodium and chloride, okay, calcium chloride, magnesium chloride, and sodium bicarbonate. These are some very important salts in the body. Now, because when they get into our body, they separate into sodium, the sodium cation and the chlorine anion, and these have charges, and they can conduct electricity. And when these were first discovered, scientists found out that they could conduct electricity, and so we call these very important salts electrolytes. And so these are electrolytes in our bodies, and so they are very good in helping our body to conduct electrical impulses. And so we call these electrolytes. And if you take something like Gatorade, they always tell you Gatorade has lots of electrolytes in it, and presumably that's good for your muscles in their conduction of electricity. And so these are four of the more important electrolytes in the body: sodium chloride, calcium chloride, magnesium chloride, and sodium bicarbonate. And so electrolytes and salts are basically, you can think of them as the same thing. And here we have our electrolytes. Okay, on this slide we're going to talk about another important molecule in the body. Okay, let's draw ourselves an oxygen atom. Okay, I'm going to draw the inside here. This will be the first energy level, and on this one, of course, we have two electrons, and in the nucleus we have 8 protons and 8 neutrons. Now this part is not that important, and that's why it has this color. Now the second energy level, or the outer energy level, this is the important one. Okay, and this is our second energy level, and on this energy level we have 1, 2, 3, 4, 5, 6. We have 6 electrons, and this is the oxygen atom. Now this oxygen atom, this is not what we breathe. We don't breathe the oxygen atom. We breathe the oxygen molecule, and the oxygen molecule is O. Well, that's kind of big. It's O2, which is 2 oxygen atoms. This is the oxygen molecule. And so let us draw ourselves another oxygen atom and put them together. So there's one oxygen atom, and over here we're going to have an identical oxygen atom. We're going to have our 2 electrons on the energy level. We're going to have 8 protons, 8 neutrons, and we're going to have our 6 electrons. 1, 2, 3, 4, 5, 6. Okay, and this is that one is not as big, but here we have our 2 oxygen atoms. Now the left oxygen atom, as you can see easily, it has 6 electrons, but it wants 8, so it needs 2 more. The oxygen atom on the right has 6 electrons, but it needs 2 more. These 2 oxygen atoms decide one day to join forces, and when they join together, now they share these 2 electrons, or well, they're sharing 4 electrons, and now they both have a complement of 8 electrons in the outer energy level, and they're both happy. And this molecule now is called the oxygen molecule O2. Okay. Now this molecule, of course, is good for us. This is what we breathe. This is the oxygen that we breathe. However, sometimes some bad things happen with this molecule. Sometimes this molecule will actually gain 1 additional electron. I'm going to put it here as purple. I'm going to make it a little bigger so you can actually see this one. Now this molecule has 1 additional electron, and because it has this 1 additional electron, this makes this molecule very reactive. And now this molecule is no longer called diatomic oxygen. This molecule is called superoxide, because it has a great ability to oxidize things. Superoxide, and superoxide is very bad for us. And because it has an odd number of electrons, that extra electron, we call such a molecule or such a substance a free radical. And that makes it very reactive. That odd numbered electron makes it very reactive. Okay, and so now it is no longer just O2. This structure is now, it's still O2, but it has a negative charge, and that negative charge is because it has this extra electron, or this odd numbered electron. And so this is superoxide. And as we've said before, superoxide is very destructive. And so let's explore what it does. Let's have ourselves a human being here. So just a very rough human being here. And so what the superoxide does, the superoxide actually attacks the body, several structures in our body, and it oxidizes. It oxidizes DNA, it oxidizes proteins, fats, anything that it can in our body. And that causes a lot of destruction in our body. And so here, it oxidizes DNA. That's kind of too big. It oxidizes fats. And it oxidizes, well, proteins, many other things, just anything that it can, it oxidizes in the body. And now it makes them free radicals, and these substances can go on to create free radicals out of other things. And so that's what free radicals do in the body. Okay. And that causes a lot of damage. Some people believe that these free radicals, they are what make us get old and eventually die, because the oxygen that we breathe is converted into these free radicals, and that eventually this reactive oxygen ends up killing us. And so the body has ways of blocking this process. The body creates chemicals that actually block these free radicals. And one such chemical is superoxide dismutase. Now, and if the theory holds, if your body produces more superoxide dismutase, presumably you would live longer. So that's something that the body produces by itself. In our diet, we can intake chemicals that block these free radicals, like vitamin E blocks free radicals. Let's see, what else do we have? Vitamin C blocks free radicals. Selenium, it blocks free radicals. And all of these chemicals and all of these substances, presumably if you intake them, they would stop the destruction of your body by these free radicals that are produced normally in your body. Now, as a group, these substances that block the free radicals or stop the oxidation caused by free radicals, they're called antioxidants. Antioxidants. And so, presumably, if the theory holds, if you intake a large amount of antioxidants, or intake antioxidants on a regular basis, you would block the action of the free radicals that are normally produced in your body, and that would prevent you from prevent the destruction caused by these free radicals, and you would not age as quickly. And that's all that we have to say about free radicals and antioxidants.